Welcome to this video on solving two-step equations. Let's get started. First of all, we always need to keep in mind our goal anytime we're solving an equation. Our goal is to isolate the variable. What does that mean? What does it mean to isolate the variable? That means that we need to get the variable all by itself on one side of the equation. That means that we're going to be moving numbers away from the variable, not towards the variable. So I always start by drawing this vertical line here so I can keep my two sides of my equation straight. So the left side of the equation is always going to stay on the left of that line and the right side is going to stay on the right. But I can move things across that boundary by using inverse operations. So remember in our previous video on one-step equations, we were asking ourselves the question, what operation is being done to the variable and how do we undo that operation? Well, right now we are multiplying 3 by x and then we are adding 5. So you might wonder, what order do I need to undo those? And the answer is actually reverse order of operations, or please excuse me, dear Aunt Sally. And generally speaking, you want to start with a number that is farthest away from your variable. In our case, our variable is x, but still on the same side. So just literally using a ruler or just looking at it visually, which number is farther away? Is the 3 farther away from the x or the 5 farther away, but still on the same side? Hopefully you agree that the 5 is farther away. So again, we start on the outside, again, from the number that's farthest away from the variable, but still on the same side, and then we work inwards. Again, another way of saying it, some people will tell you, if you think about your order of operations, usually we start at the top and move downward. When we're solving equations, we usually go this way. So we do addition and subtraction first, and then multiplication, and so on. So first I need to subtract 5 from both sides. So these go away. 11 minus 5 is 6. I can bring down the 3x. So I've done my addition and subtraction. So now I could do multiplication or division. So again, the 3 is closer, so I'm doing that second. The 3 is attached to the x through multiplication, and as always, we use inverse operations to undo things. So the inverse of multiplication is division. We divide both sides by 3. 6 divided by 3 is 2. Okay? And remember, in the previous videos, I also taught you to check your work. So we have 3x plus 5 equals 11. We could put 2 in place of the x. 3 times 2 plus 5 equals 11. So we have 6 plus 5 equals 11, and we have 11 equals 11. So we have checked our work and proven that x equals 2 is in fact the correct solution to this equation. Let's do another problem. So now we have negative 6x minus 2 equals 14. Again, I'm going to start by drawing that vertical line. Okay? So now I'm going to ask myself the same questions, right? What is my goal? My goal is always to isolate x. Okay, so right now, what is being done to my variable? So here's my variable, right? We are multiplying by negative 6, and then we are also subtracting 2. That's what's happening to my variable, so I need to make those things stop happening. So again, we need to go in reverse order of operations. Okay, so we start with addition and subtraction and work our way upwards. So to undo the minus 2, we are going to add 2 to both sides. Okay, we can bring this down, negative 6, negative 2 plus 2 is 0, 14 plus 2 is 16. Okay, now all that remains is the negative 6 that's being multiplied by x, and so we need to divide by negative 6 in order to undo that. So now we have a bit of a situation here, right? We have negative 16 over 6. So there are 3 ways to express this. We could have it as an improper fraction. We could put it in our calculator and generate a decimal, or we could write it as a mixed number. Okay? So if we want it as a fraction, we always have to reduce it. So this is not fully reduced. Both numbers are still divisible by 2. So I can rewrite this as negative 8 over 3. Okay? So this is what is called an improper fraction. Okay? Well, what if I were to try and make this into a decimal? What would we get for that? What is negative 8 over 3? Well, if you type it in your calculator, it is approximately negative 2.66666 going on forever, or approximately equal to negative 2.67. Okay? So let's think about what is the best way to express this. So if I express this as an improper fraction, or negative 8/3, that is an exact answer. There's no rounding. Okay? If I try to write it as a decimal, so maybe negative 2.67, this is what is called an approximate answer. Okay? Because it's not exact, and I have to determine or guess the number of decimal points that I would want. Okay, the other way is, of course, to write it as a mixed number. So negative 8/3, 3 goes into 8 2 times, so that's 6, and then there's 2 left over. So I could also write it as negative 2/3. So one of these is preferred over all of the others. Do you have any idea which one it is? If you want, you can pause the video and guess. Well, the answer is that we prefer to write our answers as fractions, even if they're improper. So in this class, okay, do not give decimals, do not give mixed numbers, okay? Only express your answers as fractions, even if they're improper fractions, even if the numerator is larger than the denominator. And the reason is because we don't want approximate answers. And also, if we convert them to mixed numbers, it just makes the math so much more difficult if you want to check your work. So I'll demonstrate how difficult that would be. So let's say I have negative 6x minus 2 equals 14. Okay, if I put negative 8 over 3 in here for x, it's very simple and easy to see that 6 over 3, or negative 6 over 3 is negative 2. Negative 2 times negative 18 is positive 16. And 16 minus 2 is 14. So 14 equals 14. That checks out. Okay, let's say instead of doing that, right, let's say I had instead tried to use a decimal. Okay, so that is going to give me negative 6 times negative 2.67 minus 2 equals 14. Well, what is negative 2.67 times 6? Okay, so that actually gives me positive 16.02 minus 2 equals 14. So I would get 14.02 equals 14, which is not true. Well, why is there a mistake here? Why doesn't it come out? And the answer is, again, because this is an approximation. It's not an exact answer. So a decimal approximation does not give me the freedom to readily and easily check my work. Okay, let's try the third method. What if I had put in here negative 2 and 2/3? Okay, so hopefully you can see just by looking at this, trying to multiply a mixed number by 6, that's just going to take a long time. In fact, what I'm going to end up having to do is I'm going to have to convert that mixed number back into an improper fraction. Okay, so in algebra, in higher levels of math, as we go through this, we're always going to use a fraction, even if it's an improper fraction. So don't be surprised on an exam or homework if you supply an answer that's a decimal or a mixed number, it may be marked wrong. Because again, we do not use that. We don't want a decimal approximation, we don't want a mixed number, we want a fraction, even if it's an improper fraction. All right, let's do a few more examples. Now we have negative 2x plus 3 equals 4. Okay, so again, remember our goal. Our goal is always to isolate x, to get x all by itself on one side. So we ask ourselves, well, what is being done to x? Well, x is being multiplied by negative 2, and then 3 is being added to that. So how do we undo that? Again, we look to our order of operations. Please excuse my dear Aunt Sally. And we start at the bottom, and then we work our way up. So we're going to subtract 3 from both sides. So that gives us negative 2x equals 1. Then we're going to divide by negative 2. And that's going to give me negative 1/2. Okay? So do remember that 1 over negative 2 is the same as negative 1 over 2. it's the same as negative 1/2. Okay, it does not matter where you park your negative sign, if you park it upstairs or downstairs or outside, just like it doesn't matter where you park your car, if you park it on the street or in your garage or in the driveway, it's still your car. Okay, so the negative sign belongs to the whole fraction. Again, it doesn't matter if we put it upstairs, downstairs, or outside. So again, let's remind ourselves, do we want to leave it like this? Do we want it as a fraction? Do we want it as a decimal? And in this case, mixed number isn't an option because it's not an improper fraction. So again, what is the best way, what is the preferred way of expressing this answer? And the simple thing is that we want it as a fraction. Okay, in this case, negative 1/2 can be expressed exactly as a decimal. Okay, but again, we're just going to stick with fractions, and they also make it, I think, easier to check our work. So if I put negative 1/2 in here in place of x, visually it's easier for me to see that negative 2 times negative 1/2 is positive 1, and then 1 plus 3 is, of course, 4. So we have 4 equals 4. Okay? So remember, in all of these algebra problems, you can always take some time, you can check your work, and prove that you have the correct answer. And this can guard against a whole host of problems or mistakes that are very common, such as getting confused about which side of the equation you're on or dropping a sign. Whose sign is it anyway? Let's look at some unusual equations and see if we can solve them. Here we have 5 minus x equals 12. Remember, our goal is to always isolate the variable. In other words, we want to get the x all by itself on one side of the equation. Some helpful questions that we can ask ourselves are, what operation or operations are being done to the variable, and how do we undo them? So let's look at that 5. The biggest confusion here, usually for students, is to think about the signs. So my question to you is, who in that equation does the negative sign belong to? Does the negative sign belong to the x, or does it belong to the 5? Well, remember, the negative sign always belongs to what it's in front of. So this is actually negative x or negative 1x. And the 5, if we look in front of the 5, there's nothing here, right? It's just blank. So if I wanted to, I could write a plus 5 here to remind myself that the 5 is positive. So now I've clarified what is being done to x. Well, x is being multiplied by negative 1, and then 5 is being added to it. So even though on initial inspection it might appear to be a one-step equation, it's actually a two-step equation because we're going to have to do two different things in order to solve this equation. So let's begin. So the first thing we do, remember, we always work in reverse order of operations. So if we think about, please excuse my dear Aunt Sally, right, we start with addition and subtraction on the side where the variable is and work our way up. So we undo the positive 5 by subtracting 5 to both sides. So now the 5's cancel out. Notice my x is still negative. It's not positive yet. So that tells us we're not done, right? I have not yet reached my ultimate goal, which is isolating the variable. The negative 1 is still attached to the x through multiplication. We undo multiplication by dividing. So we have x equals 7 over negative 1, and you can do that in your head or with a calculator, and you get x equals negative 7. Again, it's important to remember you can always check your work. So we have 5 minus x equals 12. So 5 minus negative 7 equals 12. Minus a negative is the same as plus a positive. So we get 12 equals 12, and our answer checks out.